Okay, so today I'd like to talk about combining like terms. We use this all over algebra. And first you see it when we start dealing with algebraic expressions, and then later on we use this actually quite a bit with equations. We use this all over the place. So anyway, I just want to start off here with the first example. I have 3x plus 5x. You'll notice that both of these have an x in them, and therefore we call these like terms. They have the same term. The term is x. And so even though they have different coefficients here, we can actually combine these two. And so what I like to do is I like to use some shapes here. And so when I'm combining these two, I've got a 3x here, which I put a little rectangle around, and I add another 5x to it. And when I put those together, you'll notice I'm going to end up with an 8x total. That's all you need to do on that one. Now here is a little bit different. Although they have the same coefficients, I just want to kind of show my point here. In this scenario, I have a 3x squared plus a 5x squared. I'm just counting things here, and so in this scenario, I'm counting x squareds. And so once again, I can go ahead and combine these two together because they're like terms. I have 3x squareds and I have 5x squareds. Therefore, I'm going to have 8x squareds total. So these problems can actually get quite complicated quite quickly. You'll notice here I've got an algebraic expression written down in which there are four terms, starting off with this 5x and all the way down ending with a 9. Once again, I want to combine what is like. And so you notice here this first thing here is a 5x. And I'm going to include that with another term that also just has an x in it. You'll notice here in the middle here I have a 6x, and so I'm going to combine those two terms. I'm going to take 5x and I'm going to add 6x, and I'm going to have 11x total there. Now I like crossing off things when I've added them up, and so there are those two. The second step here is that I have some constants that are available. We call them constants because they don't have a variable to them. Here I have a -4 here. That -4 can also go together with this +9, and I ask you -4 plus 9, that's going to give me a +5. And so my answer is going to be 11x plus 5. Okay, in this third scenario here, I'm just making things a little more complicated. But once again, I'm going to start off with a lot of terms here, and I want to look at what can go together here. So this first term, this x squared term, I'm going to look for another x squared term. Now you might look at that 3x and think that those can go together, but an x squared is different than an x. And so I want to look for another term here that has an x squared. And if I look over all the way to the right here, you will notice that I have a 4x squared. And so there is a 1 in front of this first one here. I can put a 1 there if I'd like. I have 1x squared plus 4x squared. That's going to give me a 5x squared. I'm going to go ahead and cross that guy off because I'm done with that. Just gives me a nice visual. The next thing I want to go after is my x term. I'm going to go ahead and use a rectangle, and this guy uses a circle on the first one. I have a 3x here. You will notice that there are no other x's available, so I'm just going to copy him down. He's going to be all by himself. That's going to be a 3x. I'm going to go ahead and cross that off. The last one I'm going to go after are the constants, and this time I'm going to use a triangle for those. I have a -2 here, and I have a -5 there. -2 minus 5 is going to give me -7. None of these terms can go together. This term here has an x squared, which is very, very different than an x, and obviously is very, very different than a 7, and thus your answer, simplified form, is going to be 5x squared plus 3x minus 7. I hope this video helps you out with simplifying and combining like terms. Have a great day.